Hello friends, welcome once more to class online. My name is Dami, and in this edition we shall be looking at Waec Physics 2013 question number 6 to number 10, and we shall be exploring a lot of fantastic parts of physics in this edition because we have a lot of interesting practical questions that will so much interest you and teach you a lot in physics. Now let's get down to it. Now don't forget that if you learn something from this video and you want to get more content from us that will better help you understand physics, click on like button. We have a lot to share with you that will help analyze a lot of things to you. Now let's get to the video now and to the question now. Question 6 says when the linear momentum of a body is constant, the net force acting on it is the force of 0, increases, decreases, or remain constant. Now when you know momentum is a product of the mass and the speed. Okay, so the momentum, but like you have a plane, if you before a plane can take off, it has to run first. So if there is no change in mass and speed, that means the plane is not moving, then the force acting on it is what? It's actually very simple, right? So if there is no change in momentum, then there is no force acting on it. Like if you have a plane that is not moving, then all the forces acting on it is what? The net force, the total force acting on it is 0. And that's the answer. So now, but before a plane can fly, it has to run. That means it has to gain momentum. Okay, so but if there is 0 momentum, that means if the momentum is constant, that means if the plane is not moving, all the forces acting on it are 0 points. And that is so the net force acting on the body with constant momentum is 0. And that is it. It's not actually that the plane is not moving. Even if the plane is moving at constant speed, the total force acting on it is 0. And that is according to the first law of motion. And that is number 6. The total force acting on it is 0. Number 7 says, which of the following pair of physical quantity is made up of vector? Now the first one is speed and displacement. Speed is a scalar. No vector. Vector means quantity that has magnitude and what? Magnitude and direction. While scalar are quantities that have only magnitude, right? Now speed is a scalar, means that speed has only size or magnitude. Like if you are saying the speed of the fan speed is 2 revolutions per hour. You can't say in what direction it is rolling. You can only say speed. Okay, that's 2 rev per hour, and that's the speed of the car of the fan. Okay, that's speed, but it has no direction, so it is a scalar. Now, but displacement has to do with amount, that's magnitude, and direction. Okay, and that's what we can say the car was displacing with what 10 km per hour in the north direction. So displacement considers direction because it's a vector, and because all vector quantity have a consideration for magnitude and direction, but scalar do not. Scalar consider only magnitude and magnitude only. Now speed is a scalar, magnitude only. Displacement is a vector, magnitude and direction. It has both. Force is a scalar, magnitude only. Mass is a scalar, magnitude only. Force is a vector, magnitude and direction. So 2 of them are not made up of scalar, pure scalar. Number C says displacement is a vector because it has both what? Magnitude and direction. While acceleration is also a vector, it has both magnitude and direction. So the 2 of them are vector, and this is the answer. Then momentum is vector, but length is a scalar. So the answer to that question is under vector we have displacement and we have acceleration. They are both vectors, and that is why it is correct. Can you see it on the table? Displacement and acceleration, they are both vector, but lift, weight, drag, force, momentum, velocity, they are all vectors. But scalar, we have time, distance, mass, area, density, work, temperature. These are all scalars. So this is the answer. So the answer is option C for number 7. Number 8 says, with the knowledge of surface tension is applied in the following area except what? Now, have you ever seen water that is not moving? The water surface is full of this little film. There's one film like a rubber. It's not rubber actually. It's just like on the surface of the water that is not moving. There's a film that mosquito can walk on. If you have studied it before, if you have checked water in a bucket left for a long time, you will see that on the surface of the water there's a little film that dirt, even dust can stay on top, and then mosquito can walk on it. And you know that if you drop a pin on it like this, it will stay. That is surface tension. This thing that made this pin stay on this water is the tension, is the surface tension on the water. That means the water has surface tension. So surface tension is that which makes the surface of liquid behave like it is covered by an elastic skin, and that is surface tension. So some things can work on it because of the tension. Like you have here mosquito on water. Can you see that? It is due to surface tension. But now let's take it further. The surface tension is useful for making raincoats. You know, raincoats are help to shield against rain. So how are they made? They are made by putting oil. They are made from clothes and oil. Oil material is used to make that raincoat so that water can pass through. And surface tension also prevents water from entering clothes. So the knowledge of surface tension is used by science to prevent water from penetrating or to help water penetrate clothes. Like now, if you have the raincoat is made of oil material so that water can penetrate, because the water has a surface tension. It has this elastic skin. So when they put oil on it, the water will not be able to enter the clothes. Then manufacture of palm oil. Manufacture of palm oil, do they use surface tension knowledge to make palm oil? That's not true. Floating of needle on water helps, like I showed you before. This can stay on water because of surface tension, and that is true. Now here we are washing of plate with soap water. Yes, the soap can wash plate and can wash clothes, because when you put soap in water, the surface tension on the water dies. So the water will be free to enter. Natural water has surface tension, but when you pour soap on it, you have eliminated the surface tension. That even if mosquito land on that water, the mosquito will not be able to walk again. It will sink. So you have removed the surface tension of the water by pouring soap in the water. So, and that helps for washing clothes, because when there is no more surface tension, then water can enter clothes and wash that clothes well. So it is by the removal of soap of surface tension that water molecules can enter your dirty clothes and help you wash your clothes. And that means that surface tension helps to wash clothes. That means surface tension helps to wash clothes. But the production of palm oil is just by rubbing palm kernel, and it's by squeezing palm kernel that we make palm oil. It has nothing to do with surface tension. So the wrong one is just the production of palm oil. Number 9 says a body is projected vertically upward with a speed of 10 meters per second from a 0.2 meter above the ground. Calculate the total time taken for the body to reach the ground. Now this is simply motion question, right? And you can see all your parameters there. We have speed, that's v. It is projected vertically upward, that's my u. If it's going up, that means my initial speed u is 10 meters per second. But the maximum speed v is 0. Okay, it's got to a 0.2 meter above the ground. 2 meters above the ground is your distance. Okay, 2 meters. Then you are finding time, right? You are giving g, right? So you will have to use the equation of motion. Now since it's an upward motion, it is against gravity, so the equation of motion that you use will have to be negative, and therefore the equation to use is therefore v equals u minus gt. Why? Because this equation has all the parameters in the question. Okay, there is a v, final speed is 0. There's a u, initial speed is 10. Then there's a g, that's what we have, that's 10 meters per second. And then we have my time is t. Okay, so I can use this one. So that my u will move over here. I'm finding t, right? So v minus u equals minus gt, right? Then you will divide by g. G will come under, and that will become t equals v minus u over g. Of course, my final speed, if you throw something up, the final speed, it will get to a point where it will stop. So your final speed is 0, but your initial speed is actually given to you as 10 meters per second. So now I will put it in. V, my final speed is 0, and my initial speed is 10 over g, and that's minus 10. Minus cancel minus 10 over 10 is 1. Time is 1 second. Total time is actually 2. Now I've gotten my time now, but the question said find the total time for the body to go up and come down. So that means for the time that I found here is just the time for the body to go up, but the time for the body to come down again is double of the time. You know, this question focuses on the time it takes for the body to reach the maximum height. If you throw up a stone, the time it will take for the stone to reach the highest point is this small t. But the time for the stone to come down is double the time. So that becomes 2 times the normal time to reach the maximum height, and that's 2 times, since my t is 1, it becomes 2 times 1, and that will become 2. So my total time to go up and come down is not c, is actually b, and the answer is 2 seconds, and that is the answer. Number 10, a car starts from rest and cover a distance of 40 meters in 10 seconds. Calculate the magnitude of the acceleration. This is also a motion question, right? So you use the motion formula. From rest means that the initial velocity is 0. If something is resting, that means if speed at that point is 0, so the u, initial velocity is 0, then the distance is 40 meters, time is 10 seconds. Find the a, acceleration. So now the formula that has all these things in the equation of motion under motion is the second equation. S equals ut minus plus 1/2at squared. It is not an upward motion, so it will be a minus. It is just normal ordinary motion. It will be plus. So now my u is 0, my distance is 40, my speed is 0 times time, my time is 10. So even 0 times 10 is still 0. That's cancelled. Then plus 1/2a, I'm finding my acceleration times my time is 10 squared, right? So that will give me 100a over 2 equals 40 equals 100a over 2, right? And that will, if I multiply, it will become 100a equals 2 times 40 is 80. Then divide by 100, 80 divided by 100 is 0.8, and that is the answer, 0.8 meter per second square. And that is my acceleration for number 10, making option B the correct answer. And that brings us to the end of this video. Don't forget, if you learn something and you want to learn more and get more videos from us, click on like button. We have a lot to share with you that will better help you understand. But we'll see you guys. Take care of yourself and bye for now.